Okay, so let's take a look at symmetric encryption and asymmetric encryption. So you are over here, person A, the sender, and you want to send data to your friend who is person B. So to send data across the internet, you can send a packet like this. And this can contain your message, such as where you want to meet location, right? However, what happens if there is a person listening to this? So there is a person called person C who can intercept your information and therefore read what's inside your packet, and they'll know where you're meeting up. Now, this could be any situation where you're sending passwords or whatever. So we need what's called encryption. And what encryption does is it takes your message and it transforms it by scrambling it into a random set of characters. So if C were to see this going across the internet, they would have no idea what it is, and then B can decrypt it. Now, there are two ways to go about doing this. There is symmetric encryption and there is asymmetric encryption. And we're going to see what both of these do. So let's take a look at symmetric encryption. You have sender S, receiver R, and interceptor I. And the way symmetric encryption works is S and R will agree on what's called a key to encrypt the message that S wants to send. So let's say S and R agree on a key called K. What S now can do is encrypt M with K like this, K, M, and this is the encryption process. And then this is going to generate an encrypted message, like say this. And then this message, $7, this can go across here and I can intercept it, and they'll just be able to see not the original message M, but the encrypted message. And then when R receives the encrypted message here, what R can do is decrypt it by using the same symmetric key. So this is the symmetric key. And S, sender and receiver, have the same one. So R is going to decrypt this key, and this is going to give the original message M. So now R can read the message M, which is what the sender wanted to send after all. However, how do they agree on the key? How does the sender and receiver agree on the key? Well, this is the issue. They have to communicate with each other. So S and R may say, should we agree on K? And to do that, they would have to say, okay, let's use K. So S will say, send K to R, or R will send K to S. So R says, here, let's use K as our key. Well, I can intercept the K. So now I has K. And so now, when S has K and R has K, they both have the symmetric key, and S encrypts the message to get some random encryption. This encryption, the encrypted message, will go across, which I can then take, right? Which is okay on its own. I can't read the message. However, because I has intercepted the key, I can simply apply the key to the encrypted message to get the original message M. So that is an issue with symmetric encryption, because the same key is used to encrypt and decrypt, and it must be transmitted across the network. Interceptors can take it. So now let's take a look at how asymmetric encryption solves this issue. So the way asymmetric encryption works, two keys are used, a public key and a private key. So how this will work is if we have a sender and a receiver, the receiver generates the keys. So the receiver will generate a mathematically related public and private key pair. So it will say public key, private key, pair. So these two are generated together. And then what the receiver will do is it will send the public key across to S and say, here S, use this public key, use my public key of R to encrypt the data. Now I is here and I can still intercept that. So let's say I has intercepted the public key here. And we'll see how this works. So now I has the public key, S also has the public key, and S is going to encrypt the message with the public key. So M is here, okay? And this is going to generate, again, some encrypted data, like this. So public key, we're encrypting the message with the public key to get an encrypted message. And now S can send this across. So S is now going to send this encrypted message, right, to R, which I can intercept. So let's say I now has the public key and the encrypted message. So it can't read the original message yet. Well, what can I not do? I cannot decrypt this message because we cannot decrypt with the public key. The public key is for encryption and the private key is for decryption. So how is R going to read the message? Well, R now has this message. So let's recap quickly. The receiver said to sender, encrypt with the public key. The sender encrypted the message with the public key. The sender then sent the encrypted message. And now finally, the receiver is going to decrypt the message with none other than the private key to get the original message, like this. So the receiver was able to read the original message. However, our interceptor unfortunately does not have the private key. Unfortunately for them, they only have the public key, and the public key cannot decrypt our encrypted message. So this is how asymmetric encryption works, by overcoming the shortcomings of symmetric encryption by sending a public key, which the sender will use to encrypt, but making sure they always keep their decryption key, the private key, on them at all times.